YouTube. Time again for some more Game Boy game development. We're back on the fundamentals here. As you might know, last time we drew the sprite to the screen, and that was it. That particular video was following on from where we drew the background to the screen. Now this time we want to be able to move the sprite, and to do that we need to read the inputs from the keys, the D-pad, well, specifically the D-pad for moving it. To do that though, I want to just carry on with this project, but in this one we just simply drew the sprite in the main routine of the program. This time I want to create a separate assembly file for the player, and this face is going to become our player. We're going to be able to move him freely on the screen. So to do that, first create a file. And pretty sure he's going to want access to hardware.inc. I don't know why it has to default to that, because you have to change that. And player doesn't have to contain a great deal right now. If we wanted to, we could put the sprites there, but I think I'm going to keep all my sprites in one place, right where they are. Sorry, there's some strange alarm going on outside my house. Never heard that one before. So we want to create a player, and we want to be able to move him. So we'll need a space to keep some variables. And seeing as we're using the player a lot, i.e. it's probably going to be one of the variables that gets accessed more than any other in our software, in our game, I opted to use HRAM. As I mentioned in other videos, that's a very limited space. It probably would work just as well in WRAM. And here we're just going to create our variables. I've made them global because we might want to access them from another routine, such as an enemy routine. And for this simple example, we're just going to use 1 byte per position coordinate. In other videos later I'll be using 2, and we'll get onto that another time because that's a bit out of the scope of absolute beginner stuff. So now let's do our ROM code for the player. I'll create another global label. Then all this can be local. Well, no, we want that to be global as well, actually. We want to be able to call that from the other routines, from the other scripts. This is where we'll initialize the player, and we just want to initialize these 2 variables for now, I guess. Oh. All right, so we've given player those variables, and we've given those values to those variables now. If we just want to get back to the state we're in, we will not need this anymore. What we'll actually want to do there is call player.start. For some reason that's not showing up. Possibly because I haven't linked them all together yet. Maybe that'll work. That should still work. This constant resides in hardware.inc. That's why we're able to see that. Instead of hard coding the 80 there, we actually use the player's variable. There's definitely more optimal ways of doing this, but I find this the most readable way. Like if they're adjacent in memory, you can just you can point HL at the first one, just step up, increment it, etc. But let's not worry about that right now. So in theory, this should now just be exactly the same as what we got, and I don't think we need any more. Oh, we want to be able to return from the initializing. We'll need to adjust our build script. If I do Shift Alt and down, it duplicates the line. Change that to player. Grab that and paste it at the end there. So it's not very visible, is it? But hopefully you get the gist. I added this line and I added this small bit at the end of the next line. Alright, let's save that. It's not giving me any errors, which is nice. We can check our map. What did I want to check that for? I've forgotten. Oh yeah, player and player variables has been positioned automatically and correctly. So we can see that's compiled. And yeah, it's all there. Let's just double check this is working by putting that at like 120. Yeah. So we're looking good. Technically this isn't needed because we're going to do this every frame anyway. You don't need to initialize it in that way, but why not? Why not do it anyway? Alright, so we simply just want to move the character, but we need to be able to read the keys. And I think we'll pretend at the moment we'll carry on into player, and we'll pretend that we already have a way of reading keys. So we want an update function, and that's going to be global. And in there we're going to have a set attributes. That can be local. And we want to return there. So we'll call update. It's going to automatically go through there and return. That is setting our attributes. It takes the player's variables. At the moment, we have no way of telling it what tile it is. It just thinks it's tile 0 every time. And also the flags are always 0. That's fine. Because that is the case actually anyway. So, you know, when I say that is the case, our sprite is tile 0 and he doesn't need any flags ever. So this is adequate. Update actually needs to do nothing. What you would do there is stuff like maybe collision detection or animation. You could change the tile reference. You can also change the position if you are working with like a velocity every frame. But we're not going to be doing that this time, so that's adequate as it is. The next thing we're going to do is actually, do I want, yeah, that can go there. Move left, return. Again, it's global and it's really simple. You know, we just have to point HL at player X, and to move left we would deck HL. We deck the value inside HL, not the actual memory pointer. Super straightforward. Same again. Don't know what I'm doing half the time. The only difference is your ink. Alright. Moving left and right is going to be fine. That's all we need right now. Now, check keys. Let's make this into a routine. That doesn't exist yet. Let's make it a capital, why not? I'm going to put this in here, in Game Boy helpers. Something we're going to use in every single project. And we'll be able to return out of it. Now, how do we want this to work? Well, this is one of those things where I worked on it myself for a long time, and in the end I copied someone else's code which does it much better than mine. So this is another one of those things that's going to be a struggle to explain fully. Kind of tempted, I think I'm going to have to just paste it in, because line by line I'm struggling, if I'm quite honest, to explain it all. That's the notes. So a debounce state is the key just pressed right now, and as soon as it's been pressed for more than one frame it goes back to 0. But is key down, that's a permanent raw state if the key is held down. So maybe put held down. And let's just copy this in as well because it's quite hefty. Hopefully this is readable. So I mean, it's very bewildering. Very, very bewildering. CPL, that's going to invert the bits. I know that much. And I believe that's because, like, in the keys, 1 means the key's not pressed and 0 means it is. So they've inverted it for whatever reason. But you can see it is quite complicated there. And the reason that's extra complicated is he's getting this debounced state. It's really hard to explain. I must admit. This is one of those things I've talked about. I just use them. I don't always know how everything works. It's very well documented. This will appear on my GitHub. I don't know who I stole this from, I'm afraid, but it's in one of the documentations online. And as you can see, we do need 2 variables there. So just all we need to do is just create these variables so that it can use them. They are 1 byte each. And let's just use that function. Let's not rewrite the Bible, you know, like we don't need to. Let's just use it. So here's our section for the helper routines. We're going to just need a section for helper variables. And we'll use those in I mean, do I want to use HRAM? Yeah, I think I do. I think I have to, in fact, because I see LDH here. Can't ever get it right. No, no, it's not DS10. I don't know what I'm doing. We're creating the labels. There we go. That's just for the routine to use so that it can store the state and check it to see whether it's already pressed or whether it was just pressed. It just wants to check its previous state, basically. It's not as scary as it looks, but I'm not going to sit here and explain it. There's no way I'll get it right on the video here. But this is enough to know that B is going to return its raw state and C is going to return its just press state. We're only going to care about its raw state, and here are the bits for each button that are pressed. Simples, yeah? Don't forget to make the variables as well. So now we're calling that, and we know that after calling that, B is going to be containing the values we need. I think I'm going to copy paste this again to keep the video time down. It's just saves me typing it wrong or whatever, to be honest. It's not that much. This is what I copied. Let's get rid of that. No, that's not. So I think I've told you about anonymous labels, but I'll tell you about it in a minute. So there's where we were a minute ago. We called check keys. And now we've conveniently labelled this. As you can tell, I've robbed this off someone else. Move up and move down don't exist yet. This was already there. So this is the bit we've copied and pasted. The anonymous label just says jump to the next anonymous label there. And that it's really simple. So it's just checking the bit. Button A is 0, etc. Yeah. So to check right, we want bit 4 here. And if it's not pressed, jump to left. It's that straightforward, yeah. And if it is, we call this. So all we need to do now is call player update anywhere before that DMA transfer. Oh, why can I not type? I'm terrible. Player.update. That's going to stop there. So it's going to do that every frame. It seems so simple. This should work. Knowing my luck with experience on these videos, this isn't going to work, and then we're going to be messing around. But let's have a look. Oh, it works. There we go. Alright, so let's add in up and down. Moving up is actually decrementing the value. So obviously down is incrementing it. Alright, we'll uncomment those because somehow they were magically already there for me. Hey, I like it, I like it. It's looking good. We've already got a game. As you can see, that is the minimum speed. It's not really adequate. Like you can make a game like that, but very soon I'll be showing you like I think they call it fixed point accuracy, and we'll use a second byte for each of the player position values. In fact, we'll do that in the next video. So we'll change that to 2 bytes, and we will increment it in a 16-bit nature, but we'll only use the top byte for the value that we set the position at. So you know it will go up slowly. It will take a set amount of frames to actually tick up. So this one was short and snappy, I think. I don't even know the time on the clock, but I'm pretty much happy with this one. This shows you how to add keyboard input, and it separates the player into his own assembly file for much better use later. We'll be adding, you know, all sorts to that later. The next video, I'm going to show you what they call meta tiles, meta sprites, where we can display more than, you know, a sprite that's larger than 8 pixels. What else can I show you next time? Well, I've already told you the fixed point accuracy on the movement. So we're doing meta sprites and fixed point accuracy coming up soon. And hopefully even today I might have time to film those. So see you very shortly with those. But until the next time, have fun. Don't do anything too naughty. See you soon.